Okay, in this video, I'm going to show you how to work out various kinds of indefinite integrals involving polynomials, exponential functions, and we'll even see the logarithmic function come into play. This is one rule that I haven't used in these videos yet. The indefinite integral of 1 over x dx is natural log of the absolute value of x plus c. Don't forget the absolute value. That's necessary because the natural logarithmic function is only defined for strictly positive arguments. We will also need the rule for exponential functions. The integral of e to the x is itself plus c. And we also need the power rule. The integral of x to the n is x to the n plus 1 over n plus 1 plus c. As long as n is not equal to minus 1, so we're not dividing by 0. But the case where x is equal to minus 1, that's 1 over x, and that's already covered by this rule. So we can handle any power of x one way or another. So here are three problems that I'm going to work out. In a couple of these, it's necessary to rewrite the function inside the integral sign. That's called the integrand. Rewrite the integrand, and then we can apply these rules. And that's certainly the case for this function right here. Here we have a product of functions. We are not going to really have a counterpart to the product rule for computing derivatives to handle integral over product. What we need to do is rewrite the function so that it no longer is a product, and then we can use these rules down here. So what I will do is I will take this x to the 6 and distribute it through a 5x minus 3, and then we'll have something in a form where we can use the power rule. So that will give me integral of x to the 6 times 5x. So it's 5x to the 7th, and then minus 3x to the 6th dx. Now, using the fact that the indefinite integral is a linear operation, I can write this as 5 integral of x to the 7th dx minus 3 integral of x to the 6th dx. Now, you don't have to write it this way as an intermediate step. I'm just doing it to show you to boil it down to the integrals of the simplest functions possible so that you can see directly how the rules are applied. Once you get the hang of it, you can avoid this intermediate step right here. So the integral of x to the 7th is x to the 8 over 8 minus 3. The integral of x to the 6 is x to the 7th over 7. And we can hold off on adding a plus c until the very end. So once we modify this algebraically by distributing an x to the 6th through the rest, then we get something that was relatively easy to handle. So this is our final answer to the first one. Okay. Now, for the second one, we don't need to do any algebraic manipulation like that up front. I'm just going to apply linearity again. This is the same as 5 times the integral of 1 over x dx minus 3 integral of x to the minus 1/7 dx minus 4 integral of e to the x dx. Now, so all these integrals, all three of them, fit one of these rules, one each. So for the first one, we have 5 times the integral of 1 over x is natural log of the absolute value of x. And then I have minus 3 x to the minus 1/7. Well, what we get there is x to the minus 1/7 plus 1. So minus 1/7 plus 7 over 7, which is 6/7, so positive 6/7. And then we have to divide by that. So divide by 6/7. And we'll simplify this in the final step. And then I have minus 4. The integral of e to the x is e to the x plus c. So now I just need to clean up this second term here. So I have 5 natural log of x minus 3. Dividing by 6/7 is the same as multiplying by 7/6. And I have x to the 6/7 minus 4 e to the x plus c. So 3 times 7 over 6, that simplifies to 7 over 2. So the 3 will cancel out, and then down below we'll have a 2. So our final answer for this one is 5 natural log of x minus 7/2 x to the 6/7 minus 4e to the x plus c. Okay. Now, for the last one, we have to do a little algebra up front. What we need to do is break this up into 3 fractions and then simplify. So we need to actually compute this quotient. So the way it is written now, we're not able to apply any of these rules. So 7x squared, well, I'll write it this way. 7x squared over x squared plus 4x over x squared minus 5 over x squared. Now we'll simplify each of those fractions. So 7x squared over x squared is 7. And then 4x over x squared is 4 over x. And then I have minus 5 over x squared, but that can be written as, it's best to write it as 5x to the minus 2. Because that way, now all these terms fit the form of the power rule. Now, if I pull out the constants, so I have 7 times the integral of 1 dx, and then plus 4 integral of 1 over x, minus 5 integral of x to the minus 2 dx. Now, the integral of 1, that's the same as x to the 0. So that will give me x to the first over 1. So the derivative of x is 1. Going the other way, the integral of 1 is x. Okay. Then we have plus 4 integral of 1 over x is natural log of absolute value of x. And then minus 5 x to the minus 2 using the power rule. That's x to the minus 1 over minus 1. And then plus c. Now I'm going to separate my work here on these two problems. So now I just need to clean this up. So I have 7x plus 4 natural log of x, natural log of absolute value of x. And then minus 5 over minus 1 is plus 5 x to the minus 1, but that's the same as over x plus c. And that is my final answer this time. So if the integrand, in other words, the function you're integrating, does not fit a form of any of your rules, right off the bat, you may just be able to get it to fit that form by rewriting it, by carrying out certain algebraic operations like distributing or separating fractions and simplifying, things like that. So watch out for that before you actually start trying to use these rules, because it has to fit the form of those rules exactly before you use them.